And today we are going to have a very good time doing our first stoichiometric exercise. Let's get to it. The things you're learning in this video are very important because if you become familiarized with them, you will have half of the topic set up. So, no more words, let's get to it.
Binnacle project.
It says that calcium carbonate reacts with hydrogen chloride in order to form carbon dioxide, water, and calcium chloride. And the first thing we're going to do, of course, is to balance the equation. Well, one calcium atom on the left, also one calcium atom on the right. One carbon atom on the left, and also one on the right. 3 oxygen atoms on the left, and 2 plus 1, 3 oxygen atoms on the right. 1 hydrogen atom on the left, but 2 on the right. So let's place here number 2. And we have already the number of hydrogen atoms balanced, and also the number of chlorine atoms on both sides. Okay? That's it. And now they are telling us that when reacting 500 grams of this first substance, how many grams of this other one will be necessary? And this is the typical stoichiometric calculus. They are giving us an amount of substance and they're asking us to calculate other substances. Okay? This is stoichiometry. And what are we going to do? Look, it's very easy. First of all, let's place 500 grams of calcium carbonate here. And there comes the first conversion factor. What does it serve for? It will help us to change from grams of calcium carbonate. That's why we're placing grams here in the denominator in order to kill this other one and move into moles of calcium carbonate. And I tell you that only 1 mole will be enough. But which one is the number that we shall put here? Very easy. Just let's add the mass numbers of these atoms, which you can read them in the statement. Calcium atom, 40. Carbon atom, 12. And 3 oxygen atoms, so 3 multiplied by 16. Now it's time to introduce them in the calculator, and you can see that it gives us 100 grams per mole. Okay? 100. That's it. Don't forget this first step. It helps us to move from grams of the first substances we are dealing with in order to move to mole, because as you know, an stoichiometric equation works with moles, not with grams, but moles. Having said that, let's place the second conversion factor. What does it serve for? It will help us to move from moles of the substance we are coming from to move into the substance they're asking us for. Okay? We are crossing the river. We are moving from calcium carbonate and we are getting into hydrogen chloride. And which are the numbers that we are going to place in these positions? The stoichiometric numbers, okay? 1 for calcium carbonate and 2 for hydrogen chloride. So that's why it's so important to balance correctly, properly the equation. And now that we are already playing with hydrogen chloride, it's time to place the last conversion factor, which is similar to this one. It will help us to move from moles of hydrogen chloride, so that's why we're placing mole of hydrogen chloride in the denominator in order to kill this one. And let's move to grams of hydrogen chloride. Just like here, with 1 mole, we will do the calculation. And let's add the mass numbers of these elements. hydrogen, you can see it in the statement, 1. And chlorine, 35.5. And if you add them up, we have 36.5 grams per mole. 36.5. If you have in your hand 36.5 grams of hydrogen chloride, you have 1 mole of this substance. And that's it. Now I want you to put it in the calculator, and let's do 500 multiplying 2, multiplying 36.5, and divided by 100. And we will need 365 grams of hydrogen chloride to make these 500 grams of calcium carbonate react. That's it. Well, what do you think? Easy, right? Don't forget the situation. Typically, they are giving us grams of a substance, and this first conversion factor will serve to move from grams of that substance and to move into moles of that substance. The second conversion factor is like crossing the river. We are moving from moles of the substance we are given to move into moles of the substance they are asking us to calculate. And of course, the last conversion factor will serve to move from moles of the substance they are asking us to calculate to move into grams of that substance. Calculator, and that's all.
Binnacle project.
As I had to erase the whiteboard, I placed here the result of the previous section in order to calculate the products, because the second section they are asking us to calculate how many grams of carbon dioxide, how many grams of water, and how many grams of calcium chloride. So let's do it, and it's similar to what we've done before. Look, as we are calculating 3 substances, let's place here 500 grams of calcium carbonate in order to inject the conversion factor. 500 grams of calcium carbonate. 500 grams of calcium carbonate. And the first conversion factor is similar as the previous section. We are moving from grams of calcium carbonate into moles of calcium carbonate. With 1 mole will be enough to do this first calculation. And this is 100 grams. Don't forget that we have added the mass numbers of these atoms. If you have in your hand 100 grams of calcium carbonate, you have 1 mole of that substance. Now it's time to cross the river. Let's place the second conversion factor, which serves to move from moles of calcium carbonate into moles of carbon dioxide. And here we place the stoichiometric factors, the stoichiometric coefficient, 1 and 1. Now it's time to move from moles of carbon dioxide into grams of carbon dioxide. Just as here, with 1 mole will be enough, and we just have to add the mass numbers of these atoms, 12, due to the existence of carbon, and 2 oxygen atoms, which mean 2 times 16. Please put it in the calculator, and you will have 44, okay? 12 plus 2 times 16. 44. If you have in your hand 44 grams of carbon dioxide, you will have 1 mole of that substance. And now it's time to put it in the calculator. Let's do it together. 500 multiplying 44 divided by 100. And it gives us 220 grams of carbon dioxide. Can you see how easy it is? you are doing your first stoichiometric calculations. So now we are using the same procedure to calculate the grains of water and grains of calcium chloride. And if you want, you can stop the video or mute it in order to do it by yourself. Let's go on. Water. The first conversion factor is quite similar. 100 grams of calcium carbonate are 1 mole of calcium carbonate. The difference is here in the second conversion factor, because here we are moving from moles of calcium carbonate to get into moles of water. And now there comes the stoichiometric coefficients, 1 for calcium carbonate and 1 for water, 1 to 1. And the third conversion factor serves to move from moles of water to get into grains of water. And as usually, with only 1 mole, we will do our calculation. And let's add the mass numbers of these elements. Hydrogen, 1. But as we have 2 atoms, 2 times 1. Plus oxygen, 16. And 2 plus 16 is 18. If you drink 18 grams of water, you are drinking 1 mole of water. And now it's time to introduce it in the calculator, and we will have the grams of water produced. Let's do it together. 500 multiplying 18 and divided by 100. It gives us 90 grams of water. 90 grams of water will be produced. Easy, right? And finally, we are using the same procedure to calculate how many grams of calcium chloride are we going to obtain. So the first conversion factor is always the same, because it serves to move from grams of calcium carbonate into moles of calcium carbonate. With 1 mole will be enough to do this calculation. And the second conversion factor moves us from moles of calcium carbonate to get into moles of calcium chloride. And there comes the stoichiometric coefficients, 1 for calcium carbonate and also 1 for calcium chloride, 1 to 1. The stoichiometry between these two substances is 1 to 1. And there comes the last conversion factor with, as always, it helps us to move from moles of calcium chloride to get into grams of calcium chloride. As always, with 1 mole we can do the calculation. And now it's time to add the mass numbers of these substances. Calcium, 40, as you can see in the statement. And 2 atoms, 2 chlorine atoms, 35.5. Okay, let's introduce it in the calculator. And we have 40 plus 2 times 35.5. It gives us 111 grams of calcium chloride. If you have in your hand 111 grams of calcium chloride, you will have 1 mole of that substance. And now it's time to introduce it in the calculator to see the grams of calcium chloride that we are obtaining. 500 multiplying 111 divided by 100, and it gives us 555 grams of calcium chloride. And the section is over.
Binnacle project.
And finally, look how beautiful is the last section. It says that verify that Lavoisier's law is satisfied. What does this law say? It says that in a chemical reaction, If you add the amount of reagents, if you add them up, 500 plus 365, which is 865 grams, equals the amount of products. Please use your calculator to do 220 plus 90 plus 555, and you will obtain also 865 grams at the products. And that's it. We have already done our first stoichiometrical calculations, and if this is your first time doing this, please memorize everything we've done, because if you become familiarized with this, you will have half of the topic already set up. So, congratulations. And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!